Okay. All right, let's get started. So for people who are joining this live stream, this is a internal design meeting talking about future features of Wolfram Language, part of our incremental language design series that involves small but collectively important new features that we're looking at for the language. So let's get started with scale convert.
So this is a suggestion from a user asking for a way of converting these very large names of numbers. So probably the implementation in unit convert is not the right way to do it. This could be done in one of the...
Do we care? I mean, is there some way, if you type in a number, I'm not sure we have the right people here, but I mean, if you type in a number, if I say interpreter of integer 5 billion or something, don't I get a result? No, that's interesting. Oh, maybe I have to say semantic integer. Yes, I do get a result there. So what is the difference here? Is the issue that semantic integer isn't handling these really big numbers, or what?
I think part of the idea was we have integer name and integer string, which will give you sort of the long form name of them. But if you want to convert them on these different scales, you want to say 5 billion in millions. There's not really a way to do that. It seemed like kind of a strange operation to me, but I can see for some of these really large scales, it's maybe nice to compare them. If you're
the number of people who use octovigintillions can be counted on the fingers of no hands.
That's probably true.
Okay, so, but more to the point. So this case here we have covered. The fact that this doesn't work is arguably a bug.
So Francisco, can we handle those types of numbers with?
So you said that if we can interpret them in general, I think we have some large numbers that can be interpreted. Not sure if we have all the.
Yeah, but I mean, we certainly these are things which, as output from Wolfram Alpha, are well known to be able to be put into output, right? So let's see whether we can do it in input. Oh, we can't. Well, okay, so there's the problem. So I think this is just a bug. I do think documentation-wise, for integer name, we shall. So is it the case that we are doing this in integer name? If I say integer name of 10 to the 30th. Okay, we are doing that.
Yes, and we have only for English, by the way. That's something that it's on.
Is there a version? Is there a word for this in Spanish, for example?
There are some almost transliterations, but yes, there are in French and in Spanish.
Really? For these really big numbers? I mean, that nobody ever uses?
I think someone took the work of translating, but no one knows them, really.
Right. I mean, if I just do a web search for this, yeah, there's 10,000 hits for octovigintillion, and they're mostly dictionaries and sites about naming large numbers. This is not... there's no evidence here. Let's just do this is a corner case. This is not something that's that important, in my view. I think it is a minor bug. By the way, whoever's got background noise, could you put yourself on mute? Let's see. I think we should consider it a low priority bug for the semantic integer interpreter, and leave it at that. Anybody object to this? And make sure we've documented this part here in the integer name documentation. Does that make sense?
Yes.
Okay. Let us continue then.
Mm-hmm.
Mixed radix and integer string.
Yes. So the problem here is a difference with integer digits. So with integer digits, we effectively always prepend with base to infinity, so we can represent any number. However, with integer string, we cannot do that. And then, for example, you see that as long as the number goes beyond the product of the bases, we just give an error sign.
Okay.
So the question is whether we can do better than that, like inventing a new notation to
let me just understand this. So in this case with integer digits, somewhat peculiarly, this has an additional infinity digit as the first digit.
Exactly, yes. So if we have 4 bases, the result we get is it has either 4 digits or 5 digits if we need to extend, but never more. Now
which is a bit odd, but okay. But with integer string, because the infinity base, it's unclear how we would represent something in the infinity base as a string.
Exactly, because we have the limitation of 36 in integer string.
Boy, this is another horrifying corner case type thing. Okay, what do you propose?
Well, either to extend the notation, like we add some character which says, now we are going to change to decimals. And then
let me ask you another question. Why do we care? I mean, in other words, we're giving this message. We're saying, sorry, you can't represent that number in this mixed radix base.
Well, I guess it's a corner case. We just wanted to fill a gap here, and because we are starting to discuss recently this base 64, which goes beyond 36, it feels a bit strange that we limit ourselves to 36 when we are going to then use 58.
Well, how does the base 64? I mean, like the new stuff with hashing.
Yeah.
Right, the new, is that in this version? I don't even know if it's in this version, but let's say I say hash hello in SHA and this is not probably this is probably not auto-completing yet. Oops. This should be in the, if I'm not mistaken, at least in the prototype. No? What's wrong here? Am I misremembering this, or is it?
I don't remember.
Okay, but I mean, there's some representation in base 64.
Yes, so it's using. So our limitation of 36 is because we use the alphabet characters and the numbers. So 26 plus 10. Now in 64 they use the lowercase, the uppercase, and the numbers.
Yeah, base 64 encoding.
And
okay, so the basic point is what we really need to do here is in integer string, just like in hash, we need this notion of what the encoding alphabet is.
Right. So that's the question at the end. Should we allow users to specify their own alphabet?
Well, right now we don't. Oh, I see. We have pads the string to be drat. So, okay, so we have, I think the answer is yes, but I think we need to merge this design with the design of hash. Now, unfortunately, we seem to have this integer string, pads the string on the left with 0 digits to give a string of length len. That's a useful thing for sure.
Mm-hmm. Yeah, indeed.
But it could be an option for this case, like
sure.
Alphabet or numeric digits or whatever, and we just take the digits.
I mean, we could call it digit encoding, and then that digit encoding would be something that
it might be a list or a named unknown list, like base 64, base 58, whatever.
I agree, but this relates to what we're doing with all the base 64 encoding stuff, because we've already got a, how does this work? We were just looking at this yesterday. Don't we have, I mean, so for an integer here, we have already base 64. No.
Name it base 64 as a string.
Okay.
And the plan was also add, for example, base 58, which is the one used by Bitcoin.
And what's base 58 check?
Well,
we wanted to use the check variant. That's right. The check adds a hash and prepends a character.
Okay, so what you're saying here is that this is, what you're saying is that the base, the base here, has a bunch of names. And that probably these things are going to end up having to be named.
Yes. Now, this comes from the discussion of mixed radix. The question is, if we allow different digits for different bases, perhaps the base language is what should be generalized so that mixed radix can take different digits in different bases. It gets a bit crazy, but it seems like the right place to put it.
Mm-hmm.
Because it might be useful to have, for example, if I want an integer string in base 30, but with a different alphabet, let's say I want to use only lowercase or only uppercase, whatever, that I could put an option with the list of actual digits I want. I think that
No,
would be
I agree. I think that's useful. But now this, for example, this check digit thing is yet another piece of decoration on top of all of this, right?
Yeah, but the check part, I think, goes more with hash than with integer string, really.
Okay, fine. So integer string. So your claim is that the first step here, that what you're saying is this is really base 58 here, except that doesn't make any sense because we can't give a base 58. It seems to me that maybe what we should be doing is, in the case where this is a radix above 36, I suppose, I don't know what we're, whatever, that we maybe could give a syntax where it's 58 arrow and then an alphabet. If that's what we think we're using, we can either have named bases like this thing here, you know, quotes Base64, if those are named standards, or alternatively, just give the radix and then give arrow alphabet. And then potentially, in the case of mixed radix, we could do the same thing with either inside the mixed radix wrapper or outside the mixed radix wrapper.
I see. And all the digits would take characters from the same alphabet.
Or everyone with each alphabet. Okay.
Yeah, in other words, it could go either way.
Mm-hmm.
But this seems to me, I mean, if what you want to do is, I mean, this to me seems like a somewhat reasonable. I mean, we could also have, if we think we're going to be using it elsewhere, we should, I mean, these alphabets are going to be messy typically. Unless they're a standard, they're going to end up being messy. There's an argument, by the way, that we should put in our alphabet function, right, where we, you know, currently we have things like Russian. You know, if there is a notion of an alphabet where there's a mapping, you know, from what on earth?
Too many S's.
Oh, it didn't autocomplete. Why didn't it autocomplete? Did it autocomplete?
No.
Oh, it did autocomplete. I ignored the autocompletion. No matter. Okay. So my argument here would be that it would be good to support, since we've got a whole bunch of, you know, we've got letter number, right, which supports an alphabet, right? Letter number, character C alphabet, you know, English, for example, right? That whole set of piece of functionality could also be supported for if we had named alphabets like the base 58, you know, in other words, if we had an alphabet called base 58, that could then be supported with letter number and things like that as well, which could be useful. Does that make sense?
Yeah.
I see. So to have this list publicly available via alphabet function.
That's what I'm saying. Yes, because otherwise, I mean, what we've got is, I mean, these are string encodings. We've been sort of circling around. In fact, Itai has also been involved in the string encodings business, and maybe he should be consulted on this. I assume he's not in this meeting. Okay, so let's take a look. So for example, if we look at Wikipedia's list of Base64, right? So there's different schemes that they probably discuss. Let's see whether they discuss. Okay, so they've got a bunch of other weird random ones of these. Binary to text encoding. Okay, so this is the list. We've looked at this before, actually. I mean, I just don't know whether this is where we want to go, whether integer string on its own, or whether there's something which has to go straight from a byte array to one of these encodings. Am I making sense?
Yeah, both things seems useful. I mean, the conversion of a number into a well-defined alphabet seems something well-defined for integer string.
Yes. But I think also for byte array, what's the way of converting? I mean, there is a byte array to string function, right? That's magnificent and not very useful. Oh, because those are the actual bytes, right? So if I say 160 to 170 here. Oh, fascinating. I see. So that's a byte array. I don't really know what this is doing here. That is by default using a character encoding, which is so if I say character encoding ISO, well, what is it? ISO Latin 1 or something? Should be a character encoding. Oops. Maybe it's expecting the character encoding like that. Yeah, there we go. Okay. So how does this relate to what you're talking about? So this is a mapping from bytes into string characters.
Yeah, so this is probably a base 256 with a given list of.
Right, but so then this thing here, this character encoding, is again something closely related to your alphabet setup, right?
Right.
Look, I think my tentative conclusion is that we should do something like this in integer string. We should talk to Itai to make sure that the byte array to string stuff connects with this properly.
Mm-hmm.
And in a sense, we can think of it, I suppose, as a character encoding, in the sense that what this is saying is, you know, just like an alphabet is in a sense a character encoding where A is 1 and B is 2 and so on.
Right. Mm-hmm.
And so I think what we're saying here is that there is a mapping from character encodings, and even we could, in principle, although it's kind of silly, we could say the ISO Latin 1 character encoding is like an alphabet, except, you know, where 160 is, well, I thought, what is it? 165 is A or something. I don't remember what it is, but I thought that was what it was. But in any case, it doesn't matter. But okay, but I think this is a reasonable way to go with integer string. So why don't you see if that makes sense and see if that's implementable, and go from there.
Mm-hmm.
As well as inventorying which of these sort of quote space 58 and so on we should be doing.
Okay.
And I believe Itai has already looked at some of that. Okay, let's look at take largest.
Yes, so the question here is that we are about to start, Dan is going to implement this take largest extension to support properties like nearest. And we were wondering which other properties could be added here. And in particular, this is perhaps closely related to ranked max.
Okay, so wait a minute. Ranked max is saying, get me the second largest thing in that list.
Mm-hmm. Yes, so that's a bit like take largest. So the question
Let's
is...
just hope take largest, yes, it is.
Mm-hmm.
So it's linked. Okay.
So the question is whether, given that take largest is going to take properties, whether it should have, apart from index and element.
Yeah, but by the way, I'm sorry, I just want to raise this. Is Sushma here? Okay.
Yes.
You notice that these, in this documentation, these subsections are open here, which they should not be. I thought that might have been fixed in 11.3.
I have reported this, and Brian is supposed to work on it, but he hasn't yet. I will ask
I think
again.
it's something that needs to be prioritized.
Okay.
Ranked max only returns an individual value or maybe a span.
An individual value.
Okay, take largest returns, from here to the top or something to that effect.
Mm-hmm.
These are related, but not the same, is what I'm getting at.
So I'm sorry, what did you just say, Danny?
Ranked max seems only to return a particular element, whereas take largest returns a span, I believe.
A list,
yeah.
yes.
Yeah, a list of those things.
Okay, so, I mean, for knitting, obviously they're related, but one can't rewrite one in terms of the other very easily, I don't
Obviously,
think.
right.
Okay, just wanted to make sure I'm on the right page here.
Right. The question of listability of ranked max is an interesting one. Seems sensible to do that. I don't know why we didn't do that in the first place.
Mm-hmm. Yeah, because then it would feel closer to take largest in that sense.
The others, we're hearing typing mute themselves. I think we should do this. I don't see an objection to doing this. You might want to send out something on core design to just ask. I don't see an objection. Okay, now there's the question of what the sub-properties on take largest should be. Okay, so index would be tell us the indices that are for which we have. So I don't quite understand what this is. So tell us the indices of the 3 largest things in this list. Right?
Yes, so this is the general idea of, in many cases, we not only want the objects that obey that some property, but their position.
Right.
And so this is the way of getting both them at the same time, if we say element, comma, index.
Right. I mean, arguably, you could also want the difference between the element and the maximum or something. Although,
could be.
Which would be the analog of distance.
Right. Yeah.
Well, what would we call that? If we were going to have the distance analog, what would it be called here? We can have index and element are clearly 2 things. Okay, so what would rank do? Rank would say, rank would say for each element, where is it in the ranking of elements in that list?
Yes, it's a bit like ordering.
But I don't understand how the ranking works when there are ties.
Yes, well, it will have to do like rank max. The second and the third are the same. Well, the second and the third are the same. Now, there will be an ambiguity in which one we call the second and the third. But
yeah, but I mean, the question is, does it jump? It's like if we have a ranking, we've got the top, element, then we've got elements 2 and 3, which are tied. And then is the next element 4 or is the next element 3? I think it's 4.
Oh, so you mean that you would put two twice if they are repeated?
That's what I would think. Yes, I would think that's what we have to do. Unless we have some other. If that's the ranking, it's like if there were 2 people tied for second place, they're both in second place. It's not like second place and third place.
But is ordering doing that? Can you try ordering of that list you wrote?
This one here,
for example.
I think ordering will have a tie break.
Yeah, so the 7s are numbered differently. I would do that as well.
For a ranked type of thing, I'm not sure, Jose. I kind of like the idea of not breaking ties.
But look, if we're going to have something like ordering, we should probably call it ordering. If we say index, and if another one of those properties is simply ordering, then that would be consistent.
Yes, it's also rank. So rank, if you ask for the rank 4 and 5 of that list, it gives sevens.
Okay, I see. Humph. Let me think about this for a second. So the issue is, let's see. Do we have a case where we know we care about this?
No, I cannot think of one.
All right, let's punt on this for right now. I mean, it seems like there are, because, well, let me think. So your proposal is to add rank and have that be the equivalent of what ordering would, now what is it exactly? It's the...
Yeah, it's what ordering and rank both currently do. They consider that those sevens are 4 and 5.
Yeah, but what would we do to take this list and replace every element by its rank? How do you do that?
Right now, that's ordering.
No, ordering doesn't. Oh, yes, I see what you're saying. I see what you're saying. Ordering gives you the rank of each element.
Exactly. Now, if we took rank of that list, comma, the ordering, and it was listable, it would.
Okay, so we have a comment from our live stream from Flip Phillips, who says, in non-parametric statistics, we treat the ordering and ranking without tie breaking, usually, but not always. Yeah, I mean, the whole business of ranked max, that was set up for doing non-parametric statistics stuff. And we've got things like this, the order distribution. This is a whole can of worms. This whole tie-breaking business is a whole can of worms. We've also got the same thing with list step plot and things. How do we handle it there? Oh my gosh. Okay. And how do we handle it in quantile? Anybody know? I think in quantile we have these parameters, right? We got a bunch of background noise, by the way, guys.
That might be me, sorry.
Okay, so what on earth are these? By the way, in modern times, we would probably give string names for these, and we probably should. That's probably a small item. Sushma could perhaps take that to the statistics group, that we probably should also provide string names for these.
Okay.
We could have two different properties called, given that we have freedom in choosing the names, we can have two different properties, and one breaks ties, the other doesn't.
And when you don't, will you skip the ties? Like, for example, having 1, 2, 2, 4, if they
yeah.
Okay, listen, this is a more complicated issue because it relates to what we're doing with these other, order distribution, etc. functions.
Mm-hmm.
I think, why don't you guys try and talk to the statistics folk and see whether there's something sensible that's come out of that. And I think this concept that we could imagine, I mean, this is also an issue for sort. Sort has some kind of default tie breaking that is frankly a bit, I'm not thrilled about it, that it has that at the end of the day, sort has to sort. And the question is, if it has no other means of tie breaking, what does it do? And it has its own, internal, mechanism for, for doing that. And I think, sort is one of the functions where the show kind of has to go on and it has to eventually sort. Some of these other things that just involve giving rankings obviously don't have that same issue. Just as list step plot doesn't have that issue in some sense. It has to, is that analogy even right? That, I'm not sure. In any case, okay. So look, let's have a separate discussion about ranking and tie breaking.
Yeah.
Okay.
Yeah.
All right. Let's move on here. Curry and differentiation. I can guess from that title what this thing is about.
Yes. So this is actually a question from Michael. And
is Michael here?
No, but the question is simple. So the question, he wanted to carry and D to commute, basically. So right now in the current implementation, they don't. And if we just add this line that I added there, then they would. My work, so this can be made to work. My worry is that
how deep do the curries go, so to speak?
Yes, and this raises the issue of how do we see a partially carried function? Is it still a function, or it's already an expression because it took some arguments? So we can, for example, differentiate with respect to those arguments. That's the last line, and I think that's an interesting question here.
Okay, so let me understand this. So curry f comma 2 of A. So it's expecting a second argument.
Yes.
Which it has not been given. If
exactly.
we would give that argument, then it happily does that.
Right.
Okay. So now the question is, can we differentiate with what happens if we differentiate with respect to the phantom second argument?
We could do that with derivative, not with.
Yeah, with derivative, we can symbolically represent phantom differentiation, so to speak.
Right.
But with D, what's it going to do if there's if that limb is missing, so to speak?
Mm-hmm. Yeah, well, it can't. If we do D with respect to B and B doesn't exist internally, it will give just 0 immediately.
Yeah, fair enough. It's only in the case of the symbolically specified derivative that would work.
Exactly.
Okay. So what's the question then? What's wrong with derivative acting on the phantom B? On the phantom argument there?
Well, what Michael wanted is D acting on A, which is the new thing. So D is treating the carried function as if it was already an expression. So we have the difference between functions and expressions.
Yes. Okay, so his point is, okay, so currently it's doing this.
Exactly.
And Michael wants it to commute with curry.
Exactly, and do that.
Yeah.
Because we know the first argument will be A, so we can already do D.
What other functions do we have that do things like derivative? And what other functions are like functionals that operate in this kind of way?
Well, I cannot think of any other. There is through, which acts on heads, but
yes, although it's a weak function.
Yes, it's a map at head function.
Right. I mean, what about, is there any n? Is there any notion of n and the question of whether we can, a numeric value and whether numeric value is preserved? In other words, here's a question, okay? So here's a concrete question. So let's say I say curry of something that has an n-hold, some kind of n-hold all attribute, okay? So what happens with attributes in general in the currying world?
Nothing. I think it's impossible to propagate them.
Okay, so in particular, if let's say f was a hold all function, it already lost the game.
Yeah.
Before that happened. Now, what we would do in the function is to give the attributes explicitly. So in other words, in the curry assembly function, we would be able to give attributes. Right?
Yes.
So let's remind ourselves what that looks like. Oh, don't tell me this is broken again. I just don't believe this. Look at this. This is some goofy thing. Wow. That is super goofy. Okay, let's try it again. This really has to get fixed. Amazing. Okay. Well, at least I'm now learning maybe how to get this to work. Okay, but in any case, the curry, okay, so curry thankfully has only 2 arguments, right?
Yes.
Let's compare it with the function, which has 3 arguments. Oh boy, it barely documents it. It's interesting. We don't even give that in the primary documentation up there. Arguably, we should move that.
I think so. It's very important.
All right. Shall I make that move right now? Should I put it in?
Yeah, why not?
You know, this word pure function, unfortunately, the common usage has kind of diverged from what our meaning of this was, but I'm going to add the word anonymous here, which has become the common meaning as a pure.
Or pure or anonymous function.
Well, we discussed that again. Okay, all right.
Perhaps with the first case is enough.
I think if we said that, it would be somewhat clear.
Yeah.
And something I miss in the details of this function is the fact that you can use also, for example, function null as first argument, and then put as third argument the attributes. So that's something is not. There is no example of doing that. Even.
What can you do?
So you can create an anonymous function that can, for example, be something like this.
Yeah. So if you want to use the third. If you want to use the third argument with hashes, you have to put null in the first one.
I did not even know that. And nor does our syntax coloring. Look.
Yes, well, that's maybe the people from NEN didn't know that either.
Well, it's interesting. I didn't know. I mean, gosh. Well, we should tell the syntax coloring folk. If they, I wonder how long this has been supported. 25 years.
Yes, since ever, I think.
Okay. Well, it's not surprising nobody knew about it. It's not in the documentation. And okay, well, why don't we, let me put in a featureized line. Why don't we check on core design that nobody objects to this? Why don't we get it syntax colored correctly?
Yes, indeed, that's something we use in many places when we need anonymous functions with attributes, because this is the only way to do that.
Right.
Okay. Well, who else in this meeting has used this?
I have used it, yes.
Well, I would have used it if I'd known it existed. As a pure function that is treated as having attributes. Actually, the case, there's also the case. you know what? I should write this down as just ATTR, because really there's the case of a single attribute there.
Perhaps you can write ATTRS and then say an attribute or a list of attributes.
Well, yes, elsewhere we can do that. So as having attributes. Okay. So now, so that was a syntax coloring. In a perfect world, this would also, oh, we're calling it params instead of args.
No, you need a body.
Let's see. Or why don't we just say in attrs can be a single attribute or a list of attributes. And then that lovely link there, we need to copy over.
I think you're missing attrs.
Yes. All right, let's put in this weird case here. Function null body attrs. Can represents in which the parameters in body is that reasonable?
Yes.
Okay, but now, so this needs some whole syntax coloring, rigmarole. Okay, I'm not going to mark this as new at 11.3 because it was probably new in version 1.2 or something. If somebody wants to do the spelunking, we could find out when that was added. Okay, so where are we at here? So the question was whether curry could get a third argument, which is its attributes. Seems not completely stupid to me.
I'm not sure we are going to be able to do it because when we have multiple brackets.
You're right. I'm going to put in a futurized thing here. I agree that I don't think we can do it because I don't think we can do the sub-value. We can suspend evaluation for the sub-value
Exactly.
thing properly.
Mm-hmm.
Okay.
Mm-hmm.
Okay, that was that.
Yes, so then we don't add for the moment this extension for differentiation. We can think
I think
more
we
about
should add it. Yeah, I think it's okay.
Do you think it's okay? Okay.
I think it's okay. I mean, but let's just talk about anything else like n, for example, and how much n gets inside. I mean, is curry an n-hold function, for example?
Oh, good point. It's not at the moment, but it should be. It certainly should be, because the second argument needs to be protected.
It could be an nhold rest function.
Yes, I think you're right.
Something has gone horribly wrong with that help system there, but I think I'm running the prototype build and I can't spell attributes. You know, that did you mean should be a lot bigger. In that case, that's kind of stupid that the did you mean is microscopic there. That's something for the search. Sushma, if you could take that to the search group.
Mm-hmm.
Just dumb. That should be like 17 points bigger or something. Because I didn't even notice it was there.
I wonder whether the autocomplete should work in that field.
Of course it should work. Yes. I mean, we're working on that.
Okay, okay.
The problem is that the autocomplete, also you might just remind the search people about that for this particular case, although I think we're aware of this.
Mm-hmm. Okay.
Mm-hmm.
Okay. Is there a sequence hold play for curry? I mean, it's such a sequency thing itself. I don't know what the okay, so n hold is definitely something it should be, but should it be sequence hold? Oh gosh, I can't even figure that out.
I don't think so.
Think so either. Think about that.
Because if there are difficult cases, we can use a pure function in the first argument, and then we put the attributes, etc. there.
Yes, fair enough.
But we certainly need to protect the second argument.
Okay.
Mm-hmm. I'll change that.
Okay, let me push these documentation changes back. And I think I would hoped we would get back to the main list of ILD priorities, but I don't think we've been able to do that. But at least we got through this agenda.
Mm-hmm.
Okay, anything else for this meeting?
No.
Okay, we are probably, for people on the live stream, we are probably going to live stream our next meeting also, which will come up in just a few minutes, and is on the subject of parameterized, gosh, I don't even know how to describe it, time parameterized objects, basically. Okay, I'll talk to you all soon. See you.
Bye.
No.
Bye.
Thanks. Bye.
Bye.